Hey everyone, I'm Olivia Radcliffe, a Marketing and Technical Services Specialist at eBeam Services. I am here with Dr. Gustavo Varca. You want to introduce yourself, Gustavo?
Hello, everybody. I am Dr. V. As everybody knows me, I work here at eBeam Services. I'm in charge of the new application development department, and I guess I'm here to answer a couple of questions.
Yeah, so we've been doing this thing where we're getting questions in about different aspects of sterilization, polymer modification, just e-beam processing in general. So Gustavo has been kind enough to say he'll jump on and answer some questions for us. Lately, Gustavo, we've been getting a lot of questions about liquid processing for sterilization specifically. So brace yourself. I'll just kind of read through these and let you answer as we go. Just one word of warning for you as we get going here. Censor what you say a little bit. Don't get so excited about sharing all the information we have.
All right.
All right. First question. Can you actually sterilize liquid products with e-beam?
That's an easy one. Of course we can. It just depends on what the product is and the microorganism, because some microorganisms may require special licenses for the companies involved in the chain to process them. But radiation can sterilize viruses, bacteria, all of those alike in solid liquid state. There's no barriers there in terms of sterilization.
So, piggybacking off of something you just said, though, is there a difference between trying to reduce bacterial load versus viral?
So the reality is some of the organisms have different resistance towards high energy processing. So they have what microbiology defines as the D10, which is the dose necessary or for in this case, the dose necessary to reduce to impact a 1 log reduction on the bioburden. That depends on microorganism, right? So it's specific to each type of microorganism. And when you compare viruses or bacteria, viruses tend to require more dose than bacteria to reach a D10. So that being said, we can process both, but ultimately for a great majority of microorganisms, you would need a higher dose to sterilize viruses as opposed to the dose you would need for bacteria. Now, every bacteria is different. Every contaminant is different. I will give a spoiler here a little bit that at liquid state and solid state, the D10 values are a lot different for a variety of reasons, but I'm not going to answer something nobody asked, but it's just a spoiler.
So how do they go ahead and determine what their base CFU count is?
So they need to work with the microbial lab, like with a lab that will determine the bioburden levels they have. And in liquids, that's particularly important because they tend to keep growing, right? And that growth it's a lot faster in liquid, right? Because water is the base of life as we know it. So that tends to speed up things a little bit. But once you know the bioburden and you know that it's stable, you identify the microorganisms, we have plenty of resources available in literature to understand what the D10 value is so that we can calculate the dose for that. There are other tricks in there, but as you told me to be careful, so I'm not going to say that out loud. But for our customers, I'm more than happy to discuss and find a solution on that.
Okay. And so one of the easy ways to determine that minimum dose is using the ISO standard, right? ISO 11137.
Well, the ISO will guide you to how to qualify and validate the process, right? And you can use the standard dose that's referenced there, or you can define your own as long as you prove that your product performs and has gone through all the steps. So yes, that can be a guideline to be followed. You can also use the USP, but there's also plenty of literature that would be very specific towards the D10 values of a specific microorganism.
Okay. So what sort of packaging then are people looking at if they have liquid products to sterilize?
So it's interesting, Olivia, because there is a common thinking that people don't really differentiate liquids and solids. They use the same mindset for solids and liquids, but they ignore the fact that when we're talking about a solid, the effects we have from radiation are more what we call the direct effects.
Mm-hmm.
That meaning the effects are caused by direct energy transfer from your beam, right, from your ionizing radiation source to the matter. So those are the direct effects. That's why at solid states, in most of the cases, or if not all of them, you need a lot more dose being delivered to reach sterility levels than you need in a liquid. Because in a liquid, you have what we call a simultaneous effect of the direct effects and indirect effects. The indirect effects happen when ionizing radiation reaches the solvent. Most cases it's water, most cases it's a saline solution. That impact, and if it's a solution, it's mostly water. So the water will undergo a process called water radiolysis, and will lead to multiple reactive species, which we call radicals. Those radicals also provide sterilization because they attack organelles of microorganisms. So when we talk about liquid processing, the dose is usually lower. And now I'm going to go back to your question, which is about packaging. So if we think of a solid, we got to make sure we cover the whole area, because we're mainly talking about solid effects of radiation on solids. When it comes to a liquid, liquids by definition are a constant state of moving particles. Basically, everything inside there is moving. So there is a conception that you do have to break through the whole container, but the most important, you need to be able to make sure your radiation reaches the liquid and produces those radicals that will trigger the sterilization process, right? And microbial kill. So we prefer to have them single stacked, but I wouldn't say that we should be limiting in what we bring, because again, we can use some tools, I won't tell them all, and we go through the process and we validate them. But usually single stack for tubes is very good. And we can also work with boxes with multiple units, but the main concern is not overstacking them to make sure we can deliver a good penetration. There are other tools to overcome in case that's not possible. We have a team to work on that. I'll be happy to work with anybody on that, but I think I already spoke too much.
You're fine. You're good. So you talk about single layer packaging, being able to have the electrons actually pass through the packaging to reach the liquid enough to start that reaction.
Yes.
Is there a certain size, vial, bottle, ampule, anything like that? Are there any limitations in your mind?
Well, of course, we try, because of the nature of electrons, they have mass, right? So they will stop as they interact with matter, and we want to make sure we can reach as much product as we can. So there are some limitations. If you send a gallon, that can be tricky, get a container with a gallon. But again, there are multiple tricks and multiple tests we can do to try to overcome this problem when repackaging or an alternative packaging is not possible. Usually low volume products are easier to be handled, right, and processed by electron beaming. I would not limit anyone's imagination and say you got to bring a vial of this volume or this type. I've done processed bags, I've processed vials, and I've been surprised with the outcomes we've seen lately. So I basically say, without a test, there's no bad idea is a bad idea until you've tested and you've seen that you can actually make it work.
Okay.
I hope I answered the question, but
it was kind of it was a non-answer, but you answered with the non-answer. Essentially, there aren't too many definite restrictions that you should talk to tech services, and we will walk through whether or not there's red flags, how we can make something work.
I guess to make it easier, we're more concerned about viscous liquids than just regular liquids, or more less viscous ones, because then we also have another density challenge there that can be intensified by viscosity in some ways. And again, physicians don't, guys from physics areas don't throw tomatoes at me. But that's
so
the
there is a
reality.
difference in sterilizing something that's more of a unit density versus more viscous.
Yes, because you bring other challenges, right? You're actually, you can have a higher density, you can have more shadowing effects in a viscous liquid, but there are also good perspectives there, because one of the ways for us to know if the process is running smooth is lose or gain of viscosity. So that's another indicator that we can use to see how smooth the process is going in terms of a visual inspection.
All right.
I think I spoke too much again.
You're good. Don't worry. I'll censor you out if you say too much.
You can put a black tag.
Yes. Last question.
Yes.
About the sterilization validation process for liquids. Yes. Can you talk on that a little bit? I know it will tend to vary whether they're following USP or ISO guidelines.
Yes. My recommendation, what I've been pursuing and helping the customers and trying to help the customers being successful, is we don't skip steps. We proceed, even though we may need to use different tools that are not standard in the industry or not routinely used. I guess that's the best way to outline it. But we would go through a dose mapping phase, determine the maximum doses, and then doing the bioburden and the dose verification studies to make sure the dose is sufficient to promote sterility. And so those are the basic steps that would apply the same way. There would be a couple of differences in terms of doses, right? And there might be some extra effort in providing a lot of evidence that the product is sterile, but ultimately it follows the same path. It's more of a technological challenge as opposed to a qualification challenge, because the recipe is there, whether you use the USP or the 11137 ISO, right? You just got to make sure you're following the ISO that is your product is designed to be used, right? And for that application that your product is designed to be used for.
So bioburden testing to establish the minimum dose, material exposure with us to establish compatibility in a maximum dose.
Yes.
A dose map portion on the product as we'd see it in production to figure out the surface dose we're going to apply, and then potentially a routine dose audit to verify that minimum dose.
Yes. And when it comes to the dose map, the beauty of it is it allows us to understand the dose distribution within the production case, right, with the production boxes. And we're able to utilize and deliver the dose more in a proper way, and therefore use the minimum dose required, not to exceed it, and make sure we're getting the best out of the electron beam technology, as opposed to over delivering those, or, because as I said, effects on liquids are more pronounced than solid state. So you really want to make sure you're having a precise dose delivered to your product.
Okay, great. Well, thank you so much. We'll wrap it up there.
Thank you.
If anyone does have any questions about processing a liquid or validation or, packaging, things like that, reach out to us. Gustavo, I know, would be more than happy to talk for a lot longer about this topic. And I'd be happy to help as well. Or if you have any other questions you want us to jump on and talk about, I'll leave a link in the comment below, or there will be a link to a questionnaire form you can fill out, and we'll tackle your questions the next time. All right. Thanks, Gustavo.
Thank you.
Bye.
Bye.